welcome to this lesson. In this lesson, we are looking at Introduction to Programming. This is Basic 7 lesson, and our focus is on Introduction to Programming. So, the focus of the lesson, what we are focusing on today is we look at programming. We look at what programming is. We look at what programming is. Some terms in programming, some of the terms that is used in programming, and then we look at the types of data that we deal with when we are programming. So the last thing we will talk about is data types. So programming. First of all, what is programming? If we say programming, what is programming? So programming is the process of creating a set of instructions that tells the computer how to perform a task. It is the process of creating a set of instructions that tells the computer how to perform a task. So basically, what we are doing is that we are creating some set of instructions that will inform the computer as to what to do. So it tells the computer how to perform a specific task. So the set of instructions that we are writing that tells the computer what to do is what we refer to as program. The set of instructions that tells the computer what to do is what we refer to as program. And the programmer, or the person who is writing the program, using a specific language is known as a programmer. So this is a programmer here writing a program. So the person is called a programmer. The process of creating the instructions is called programming, and the instruction itself is called a program. Now let's look at programming languages. Programming languages, they are the language that are designed to communicate instruction to a computer. So a programming language, this is a language formally designed purposely to communicate instruction to a computer. Now there are several types of programming language, or several examples of programming language. You can see Java here, you can see Python, Swift, C#, JavaScript, TypeScript, Scala, Perl. There are a lot of them. So some examples include, we have Java, Python, C, C#, C++, HTML, JavaScript, Scala, and a whole lot of them. So these are some of the examples of programming languages that we have. Now let's look at an algorithm. If we say algorithm, what is an algorithm? What exactly is an algorithm? So algorithm is a step-by-step procedure to solve logical and mathematical problems. It is a step-by-step procedure that we use to solve any problem. So if you have a problem and you want to solve it, you have to follow some steps in solving the problem. Let's say you want to wash some clothes. If you are washing the clothes, before you be able to wash the clothes, you have to be able to follow some steps one by one. Get water, get a bowl, get a washing powder, put the shirt inside the water, and then you will wash. After that, you dry whatever you've washed. These are steps that is used to wash our clothes, and there are several steps, like when you want to eat, you want to drink, you want to cook, if you are going to sleep, you want to learn. There are basically some steps that we follow. So these steps that we follow to solve a problem is what we call an algorithm. So what an algorithm does is that it takes an input and then it will produce an output. So the input is going in and the algorithm will work on the input to produce an output. For example, if you have some dirty clothes here and you pass it through the algorithm of washing, that means at the end you have an output which will be a clean shirt. So that is an example of algorithm. Now, what are some of the characteristics of algorithm? The characteristics of algorithm or the properties of algorithm. Number one, they should have well-defined inputs. If an algorithm is supposed to take an input, the input must be well defined. It might be numbers, it might be alphabet, or some special symbols. The input should be well defined, and well defined output, if it's supposed to produce an output, the output should be well defined. Next, the algorithm should be clear and unambiguous. The algorithm should mean just one thing. You shouldn't have different interpretation, but the algorithm should be very clear and it should mean just one thing. And finiteness. Finiteness means that the program should have a start and an end. It should have a place where it is starting and it should have a place where it is ending. Then language independence. This means that the program or the algorithm should not be dependent on any language. It should just be a plain instruction that can be executed in any language. So even if the algorithm is written in English, it should be able to be executed in maybe Akan, but we have to produce the same result just as it was written in English. Then the last one is that algorithm should be feasible. It should be something that is possible. You don't write an algorithm which is not possible. So one characteristic of algorithm is that it should be possible or it should be feasible. What are some of the advantages of algorithm? What are some of the advantages of algorithm? So algorithm is easy to understand. It is something that is easy to understand. So number one, it is easy to understand. When you do a step-by-step way of solving some problem, it is easy to understand the problem. And then algorithm breaks problems into smaller pieces, making it smaller to solve or making it easy to solve. So when you break a process into some kind of pieces, you take one piece and you work on it, you go to the next one, you work on it, you go to the next one, you work on it, which means that it makes the thing very smaller to solve and very like less complicated to solve. Algorithm is a step-by-step representation of a solution. We want to get a step-by-step, one step at a time, to a solution. It is very appropriate to use an algorithm. Then what is the disadvantages of algorithm? What is the disadvantages of algorithm? Number one is that it takes a lot of time. If you are writing an algorithm, breaking the thing down one by one, breaking it into pieces, it takes a lot of time. It takes a lot of time. So what we are saying is that writing an algorithm takes a lot of time. It takes a lot of time. So also it is difficult to show some things in algorithm. If you are writing an algorithm and you want to show some statements like a branching statement or a looping statement, it is difficult to show. Looping means that some procedure is occurring over and over again until some result is produced. It is difficult to show this aspect of statement in an algorithm. A flowchart. a flowchart. So what is a flowchart? Okay, so when we take an algorithm and we begin to represent it using diagrams, the diagrams we use to represent it is called flowchart. So flowchart is the diagrammatic representation of an algorithm, or it is the use of diagrams to represent an algorithm. So that is what a flowchart. So this is an example of a simple flowchart, which means that we start a process, we read the temperature, and then the system here will determine whether the temperature is less than 32. Whether the temperature is less than 32. If the temperature is less than 32, then it will display this, that it is below the freezing point. If the temperature is less than 32, that means it will display that the the temperature is below freezing point. But if it is not so, it will print that it is above freezing point, and then the program will end. So this is the use of a flowchart to represent a specific algorithm, which is the reading of temperature and then the interpretation of the temperature. Now there are some symbols that we use. You see that we have some symbols we are using. We are not just drawing any random symbols, but each symbol here has a specific meaning. Each symbol has a specific meaning. So let's look at the symbols. Okay, so this is a symbol here. It has a name and it has a meaning. This is also a symbol. It has a name and it has a meaning. So the name of this symbol is a flow line or arrowhead. This is a flow line or an arrowhead. It shows the order of operation. It shows that when we move from this step, we go to this step. When we move from this step, we go to this step. Now we have a terminal. A terminal. This is a terminal. This is a rounded rectangle. A rectangle with rounded sides. So the name is terminal, and it indicates the beginning and ending of a program. It indicates when a program starts and when a program ends. So when you come here, this is a terminal. This is a start. This is an end. Okay. So terminal indicates the beginning and ending of a program, and a process represents a set of operations that changes value or form. So it transforms some kind of input, and then it produces an output. This is a process. It is used to the rectangle is used to represent a process. Now we have other symbols like this one. So this is a diamond shape, and a diamond shape represents decision. It represents decision. So it shows a conditional operation, which can be yes or no, or true or false. So when you come here, you see the decision. This is the decision. The decision means that the temperature can be less than this, or it can be greater. So you have two of them, yes or no. That is the decision we are talking about here. And then input output. So this shape here, like a parallelogram, indicates input or output. So this indicates the process of inputting or outputting data. If we are giving some data or we are reading some data, and we have to use the input output symbol. There's a predefined. So this here is predefined, which means that it shows a named process which is defined somewhere. So it shows a process, but that process has been predefined. It has been defined elsewhere. So when we come back to the example we have here, this is This one here, the shape here is a terminal. There is also a terminal. This here is a decision. So this is decision. And then this, and this, and that, they represent what? They represent input, output. Okay. So let's look at source code. Source code. So a source code or a code is a list of human readable instructions that a programmer writes using a specific programming language. So the code that a programmer writes using a specific programming language is called the source code. So the source code or the code is what actually tells the computer what to do. It tells the computer what to do. So example is a plus b is a source code, or a minus b is also a source code. Let's look at high level language. High level language. So what is a high level language? So for a high level language, only humans can understand it. A high level language is a programming language that only humans can understand. So it is a programming language that is only humans can understand, or that is understood. That is understood only by humans. It's a programming language only that only so this is not supposed to be here. That only humans can understand. Okay, let's look at machine language. So what is machine language? So machine language, or the low level language, for that one only machines can understand it. Only machines can understand it. So machine language is a language that only machines can understand. It is only the computers that can understand. So we have an example here. It is a combination of 0 and 1s, 0 and 1, 0 and 1. So every machine language or every low level language is just between 0 and 1, 0 and 1, 0 and 1. Then we move on. Now what is a compiler or an interpreter? A compiler or an interpreter. So for the interpreter or the compiler, it transforms or it turns high level language to machine language. It is a special program that translates or turns high level language into machine language, or it can also change machine language to high level language. So in summary here, we have high level language that only humans can understand. We have a low level language which only machines can understand, and we have an interpreter or a compiler which translates or turns the high level language to a low level language, or we can also turn a low level language to a high level language. It's just like an interpreter, where if someone is speaking French and the other person is an English speaking person, so it will translate from French to English, or from English to French, so that they can all understand each other. Now let's look at loop. Loop. When you look at loop, it's like doing something over and over again. Doing something over and over again. So if you look at this shape, it is something that occurs over and over again. That is a loop. So what is a loop? A loop asks the same question over and over again until a certain task is complete. A loop asks the same question over and over again until a certain task is complete. So if maybe you are eating, you'll be asking some questions like, am I satisfied? Am I satisfied in your mind? So if you are satisfied, that means you stop eating. Or is the food finished? Is the food finished? If the food is finished, that means you will stop eating. So that's a loop, something that occurs in cycle over and over again, like the days of the week over and over again, the months that we have, it occurs over and over again. So a loop asks the same question over and over again until a certain task is complete. Now let's look at some of the terms that we have in programming. We have some terms in programming that we want to look at. The first one is append, or append, which is abnormal end. So this means that a program terminates, or the program just ends without any information. It means a program terminating without any information. That is append or abnormal end. The program has ended abnormally. That is append. Then we have API. API stands for Application Programming Interface. It is Application Programming Interface. So it is a set of rules that we use to develop a software application. The rules that programmers follow to develop a software application is known as API. Now we have ASCII, 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 which means American Standard Code for Information Inter-Exchange. There should be a 4 here. So there should be a 4 here. American Standard Code for. So let me see if I can write the 4 here. Okay. So American Standard Code for Information Inter-Exchange. Inter-Exchange. Okay, so ASCII means American Standard Code for Information Inter-Exchange. So it is a standard that assigns letters, numbers, and other characters available in 8-bit code. So every letter that we have, or every number, or any symbol that we have, it has a specific code which is written as 0 and 1s in an 8-bit code. Okay, another term we are looking at is argument. So an argument, or simply arg, is a value that you put into a function or command. It is a value that you put into a function or command. So if you have a function like y is equal to x plus 1, when x is now 1, we have the function becoming 1 for the x here, 1 plus a 1 giving us 2. The function is y is equal to x plus 1. So when x is equal to 1, in place of this x, we write 1. So we have y now equal to 1, which is now the value of x, plus another 1. That will give us what? 2. Okay, so the value 1, this value x is equal to 1, which we put into the function, is called the argument. So x is equal to 1, or the 1 here is the argument. So an argument is a value that you put into a function or a command. An array is a list of similar types of data that are grouped together. So an array is a list of data that are similar. and then we group it together. For example, we have red, blue, green, yellow, green, red, purple, red, violet. So this is an array of what? Colors. They are similar. What they have in common is that they are all colors. They are all colors. Now there are other terms that we have in programming language. Another one is the class. The class refers to something that have common properties. So we can have a class that might be called shapes, and that one contains like triangles, square, lines, and stars. They are all what? They all belong to the same class. For example, if you go to the school, you are in a certain class, so maybe Form 1 or Form 2. If you are in Form 1, that means all of you they have a common something in common, which means that you are all at the same level of your academic ladder, and so you are all in the same class. We have command line interface. So this one, the user interface is based on only text. The user interface is based on only text but not graphics or pictures. We have conditionals. So conditionals is the feature of a program that makes a choice which can be either true or false. True or false. Exception is just like a bug. So it is an unexpected condition encountered during the execution of a program. An unexpected condition executed during the program. So an example is when a program tries to load a file from the disk, but the file does not exist. So that means it has to. That is an unexpected problem that was encountered. So that problem is called an exception. So there are other ones. The back end. The back end is a task that is performed in the background. There are some tasks that maybe your phone that you have right now is performing, but you cannot see it. So that is the back end. It is behind it at the back of what you can see. It's something that is happening but you cannot see. The front end, it is the user interface of a device. The one that you can see is the front end. The one that you cannot see is the back end. Then the boolean. The boolean creates true or false statement. It tells us whether a statement is true or the statement is false. A bug. A bug is the failure in a program that causes it to produce an incorrect result. Any mistake, any error, any failure that you have in a program that causes it to produce an incorrect result is known as bug. We have debugging. Debugging means it's the process of removing bugs, or removing mistakes or errors from a program. Expression. So expression is an accepted way of grouping letters, numbers, and other symbols. So A plus B, this is an accepted way of grouping it, which will form what we call in the math class as algebraic expression. So an expression here is an accepted way of grouping letters, numbers, and other symbols. Now the last part is the data types. Data types. So if you say data type, what does it mean? The data types indicates the type of data that a variable can hold in computer programming. So data type is the type of data, whether it's just alphabet or numbers or decimals. We can group our data into types so that the program will know how to handle those data. For example, if you have only numbers, you can add the numbers. But if you have only alphabet, you cannot add the alphabet. Yes, so the data types, it tells us the type of data that a variable can hold in programming. Data types must be used correctly to ensure the proper result and error-free programs. So the data types, if you don't use it correctly, that means you encounter problems. But if you use it correctly, you will not encounter problems. So what are some of the data types that we have? We have integer. So what is an integer? So integer is a positive and negative whole numbers including zero. That is a positive and negative whole numbers including zero. They do not have fractional parts. They don't have any decimal. They are just whole numbers without decimal. So integer, just like the math class, it is a positive or negative whole number including zero. So example is -1, 0, and 1. -1, 0, and 1. They are all integers. We have float. Float. What is float? What type of data is float? So this is used for storing whole numbers with decimals up to 6 places. So float is a type of data which is a whole number with decimals up to 6 places. So let's look at this. So we have 3.141596. So let's count the number of decimal places. Let's count the number of decimal places. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6. So you can have up to 6 places or sometimes 7. So a float is a whole number with decimals up to 6 places. Now a double. What is a double? If you say double, what is a double? A double is also used for storing whole numbers, but with decimals up to 15 places. With decimals up to 15 places. That means the double is far precise, or it is larger than float. They are all whole numbers with decimals, but the double will have decimals up to 15 places. So example is 3.141592653589793. You see that the decimals here is so many. If you count them one by one, you get 15 decimal places. Now the next one is char or car from the word character. So character or car or char is a single character. A single character is called char. So example, just F is called a char. Plus, just plus is a char. Asterisk is a char. Percentage is a char. G is a char. One or any single character, maybe a single number, a single alphabet, or a single symbol is a char. String. We say string. What is string? So string is a series of several characters. We have characters. If you have more chars or more characters coming together, you form a string. For example, hello. Why is hello a string? Because it is made up of many characters, many alphabets, or many numbers, or many symbols. So this is also what a string, because we have 4 here, we have at, we have exclamation mark, and we have the hashtag like this. Boolean is the last type of data we are looking at. So this is a data type that can only have 2 values, whether true or false, yes or no, on or off. So this is a data type that can have only 2 values. So by default, the boolean or bool is set to false. The boolean or bool is set to false, which means that it has 2 options, but the one that it will use is that it is always what? False. So example, so this is not an example. This is not an example. So example is maybe a question that will determine whether we have true or false. So neglect this one. This is not true. So what's the difference between float and double? They are all data types, but what is the difference between float and double. So the key difference between a float and a double is that double can represent much larger number than a float. So double can represent a number that is larger. Why? Because the decimal point of the double is more, up to 15, but that of the float is just 6. So you see, the double can represent much larger numbers than a float. So both data types represent decimal, but a float is 32 bits size. The size of float is 32, just 32 bits, and the size of a double is 64 bits. 64 bits. Okay, so a double is twice the size of a float. So 2 times the float, double the size of a float, is what gives us a double. So we have the term double, which means that when you double the float, you get a double answer. When you double the float, you get a double answer. So let's look at data types in daily key questions. Like in our everyday questions, we have answers, and those answers we can group them into types of data. Let's look at the first example. So I'll give you a question, you provide the answer, then you tell me the data type of the answer, whether it is string or whether it is character or whether it is float or whatever. So let's take the first question. What is your first name? What is your first name? I mean you, what is your first name? So let's say the person's first name is Isaac. Isaac. So if you take Isaac, what data type is Isaac? What data type is Isaac? Yes. Is it float, double, or it is a string? What data type is this? So this data type is string. This data type is string. Now the next question. How many times do you bat a day? How many times do you bat a day? The answer is, for the person answering, he said 10 times. Wow! This person is a miracle working person. The person takes his or her bath 10 times, which means that the person is very hygienic. So what data type is this? What data type is this? So this is an integer. Integer because it is a whole number. The next question. Ghana starts with which letter? Ghana, the word Ghana, it starts with which letter? Yes, what's the answer? The answer is J, a capital J. So what type of data is a capital J? What type of data is a capital J? So this is a char. A char because it's just one character. Then what is 3 divided by 4? If you divide 3 by 4, you have 3 oranges and you are dividing into 4 people. How many oranges will each person get? So the answer is 0.75. 0.75. That is the answer to this question. So if you take 0.75, what data type is that? What data type is that? So the data type is what do you think the answer will be? The answer is float. The answer is float. And the next question. Find the value of 2 divided by 3 to 15 decimal places. Find the value of 2 divided by 3 to 15 decimal places. The answer is very, very low. 0.666666667. So the answer is very wrong. So what type of data is this? Is it a float? Is it a char? Or it is a double? What's the answer? The answer is double. Double. Then last question. API stands for Application Programming Interface. API stands for Application Programming Interface. Is it true or false? In our lesson, we said API stands for something. Is it really Application Programming Interface? So the answer is true. True. So what type of data is this? What type of data is it? This is a Boolean type of answer. Boolean type of answer. Okay. Now let's look at constant and variable. We are almost done with this lesson. A constant and a variable. So what's a constant? Is it something is constant? It doesn't change. So in computer programming, a constant is a value that does not change for a specific time. So a constant is a variable which will never change once we are running the program. It never changes, so it is constant. It doesn't change. Now the opposite of, for example, is your date of birth. Your date of birth will never and ever change. Your date of birth, it will never change. So that's a classic example. Then you have variable, which is the opposite of a constant. So a variable is a value that can change throughout a program based on input. So for a variable, it is a value that can change. For example, the current time. The current time is not the same. It's always changing. It's always changing. Or the current temperature. There's a very high probability that the current temperature will change. So that's a variable. So why do we have to use variable over constant? For the variable, they can easily be changed. Variables can easily be changed by the programmer, unlike the constant. So the variable can easily be changed by the programmer. Then the variable enables the same program to execute various sets of data. That means for the variable, we can execute it over and over and over again. What you just have to do is that we change the particular variable. If it was 1, you can run it when it is 2, you just change it and you move on. Then variable is commonly used in programming, unlike the constant. So between constant and variable, the one that we normally use in programming is the variable. So it's better you do it because everyone is doing it. If not, you have a lot of incompatibilities as you are programming. And then the next one is variable makes a program flexible and easy to correct. It is very flexible and easy to correct. You just change one value and everything is done. Unlike the constant where you have to go and search and delete those values and correct them. It is very tedious. So for the variable, it makes the program flexible and easy to correct. So the last thing we are talking about is variables make some procedures automatic. It makes some procedures automatic, which means you don't have to go over and do it yourself. The program will just do it for yourself. For you, sorry. The program will just do it for you. So that's the benefit of using variables over constant. So we have come to the end of this lesson, programming introduction to programming basics 7. I hope you enjoyed this lesson. If you enjoyed it, if you really enjoyed it, I will plead with you to share this video, to subscribe, and then to like and share with your friends. Thank you, and I'll see you in the next lesson.